This video is to review adding and subtracting radicals. In order to add and subtract radicals, you have to have exactly the same thing under your radical. You also must have the same thing in front of your radical as far as the variable. And before you add or subtract your radicals, you're going to want to simplify them as far as you can. If you need a review of simplifying radicals, please see the review of simplifying radicals. But I'm going to go over that a little bit in this video as well. So if you notice here, I have the square root of 147x to the fifth. What I'm looking for is what perfect square will go into 147. So you always want to be thinking about your perfect squares, like 4, 9, 25, 36, 49, etc. Those are your perfect squares. You can keep going, 64, and so on and so forth. I stopped at 49. What you're doing is you're saying 147 divided by each of these numbers, and you want that number to be a whole number when you divide. So if you do 147 divided by 49, you get 3. So 147 is the same thing as 49 times 3. So all I did was rewrite 147 as the product of two numbers. And I'm also going to rewrite x to the fifth in terms of perfect squares. So x squared, and so that gives me 4 x's, and I have 1 left over. So I'm rewriting 147x to the fifth so that I'm rewriting it in as many perfect squares as I can. And I'm going to do the same thing for 48. Okay, the perfect square that goes into 48 is 16. It's 16 times 3. And then x to the fifth is again x squared times x times x. Okay, and so I'm going to highlight my perfect squares because that's what I'm going to take out. 49 is a perfect square, and my x squareds are perfect squares. 16 is a perfect square, and my x squareds are perfect squares. So those are the things I'm going to actually take the square root of. So the square root of 49 is 7. The square root of x squared is x. The square root of x squared is x. So I have 2 of those. So I have x squared on the outside. Now what I did not highlight is not a perfect square. That's what gets left inside the radical. Okay, again I'm going to take the square root of 16, which is 4. I have 2 x squareds, or I have 2 x's on the outside. What I have left on the inside is a 3x. Okay, so you have to remember what I had said was that my ending had to be exactly the same. Okay, the x squared 3x has to be the same. X squared 3x. So I have 7 x squared square roots of 3x, and I'm taking away 4 x squared square roots of 3x. So I'm going to be left with 3 of them, x squareds square roots of 3x. And that's what my final answer would be. Now we're going to go ahead and take a look at a little bit more complex problem. This actually involves multiplying our radicals and subtracting. So you're going to multiply these two radicals together first. Multiply these two radicals together. Then we're going to simplify. Then we're going to subtract. So I'm going to multiply these two radicals together, which means I'm multiplying 5 times 45, which gives me 225. Then we multiply our variables. X times x squared means we add our exponents, and we get x to the third. Y cubed times y to the fifth, again we add our exponents, and we get y to the eighth. Now we're going to multiply these two radicals together. 3 times 12 is 36. Okay, x, I don't have any x's over here, so I just have x cubed. I don't have any y's over here, so I just have y to the 8th. Okay, again, I don't have like radicals under each of these, so I can't subtract them. I have to simplify first. Well, 225 is already a perfect square, so I can just leave it just as it is. Okay, x squared x is how I would break up that x cubed, because I want to break it up into perfect squares. Y to the 8th, y squared, 4 times would give me my y to the 8th. Okay, 36 is also a perfect square. X squared x would give me my 3 x's. And then y squared, y squared, y squared, y squared would give me my 8 x's. So where are my perfect squares? 225 is a perfect square, x squared is a perfect square, and all of these y squareds are perfect squares. 36 is a perfect square, x squared is a perfect square, and all of these y squareds are perfect squares. So now that's what we're going to take square roots of. The square root of 225 is 15. The square root of x squared is x. Okay, I take the square root of each of these y's. I have 4 of them. What do I have left on the inside? Just the x. Okay, the square root of 36 is 6. I have 1 x, and I have 4 y's. And what I have left over on the inside is the square root of x. Okay, this ending is the same. X, y to the 4th, square root of x. X, y to the 4th, square root of x. I have 15, take away 6, which means I have 9. Oops, I wanted that. Which means I have 9. X, y to the 4th, square roots of x. And that is your final answer. If you have more questions on adding or subtracting radicals, please see your math teacher.